Hello friends, welcome to engineering tutorial. So in the previous video we discussed about the basic elementary particles and we got ourselves introduced to the concept of electric force and what causes the electric force, and we compared the gravitational force of attraction and the electric force of repulsion between the subatomic or the elementary particles. So in this video we are going to discuss about some basic concepts related to electric charge, okay, some introductory concepts, and then we'll go into the deeper study and analysis of all the associated and related concepts in relation to electric charge. Okay, so first, what is the definition of electric charge? How can we define electric charge? Now here is the tricky part. Electric charge is so simple, okay, it's so basic, it's so fundamental in its nature and behavior that it is very tricky and complex to define it, okay, to put a simple definition and say that okay, electric charge is that property. And okay, so it is the same as trying to define mass, okay, trying to define length or time. Okay, we cannot define them. Okay, we can only get a feel of those things by measuring them and trying to quantify them in terms of units. Okay, we can say that this is 2 seconds or 4 seconds or 6 seconds, or this is 1 meter or 100 centimeter or 10 kilometers, or this is 1 kilo, 1 kg, 2 kg, 3 kg. We can only measure them to get a feel of the real thing, but we cannot define these basic things. Okay, so these are the basic fundamental things. Okay, charge, mass, length, time. Okay, so so still, if we want to define electric charge, how can we define it? So we can say that it is the basic fundamental property, okay, physical property of the subatomic particles or the elementary particles, that is electrons and protons. Okay, only electrons and protons, not neutrons, which gives rise to the electric force. Okay, in the previous video we have already discussed about gravitational force and electric force, what causes gravitational force of attraction between two objects, what causes the electric force of repulsion between two electrons or two protons. We have discussed that. Still, this is the definition of electric charge. Charge is that property of substances or matter which contributes to electric force. So as mass contributes to gravitational force, similarly in the same way charge contributes to electric force. Now we have already discussed that electrons carry a positive charge and protons carry a electrons carry a negative charge and protons carry a positive charge. So there is always an electric force of repulsion between them. Okay, so the mass plays the same role in the field of mechanics as charge in the field of electricity. Okay, they're analogous quantities. Mass contributes to gravitational force, charge contributes to electric force. Now there are two types of charges, okay, that exist, and it is in relation with the elementary particles that constitutes each and every object which is around us. So first is the positive charge, which is present in the protons constituting the nucleus, the center of the atom, and then there is the negative charge which is present in the electrons orbiting around the nucleus in certain well-defined orbits having fixed energy associated with them. So these are the two kinds of charges that exist: positive charge in protons, negative charge in electrons. But how much positive charge, how much negative charge? We have to quantify them. Okay, so Before that, let us understand the units of charge. Okay, just like mass is measured in terms of grams or kilograms or pounds, the length is measured in terms of centimeters, meters, kilometers, miles, and the time is measured in terms of seconds. Similarly, charge is measured in terms of coulombs. Okay, it is coulomb and it is abbreviated as C. So you can say 1 coulomb, 2 coulomb, that is 1C, 2C, 3C, 4C, 5C, like that. That is the SI unit of charge. So again, coming back to the question of how much charge is present in protons and electrons, let's see that. So the protons, they carry a charge of about 1.60218 into 10 to the power minus 19 coulombs. Okay, this value 1.6, it is generally taken as 1.6. This much portion is neglected. It is normally written as 1.6 into 10 to the power minus 19 coulombs in protons, and in electrons it is the negative of this negative of this charge, which is minus 1.6 into 10 to the power minus 19 coulombs. Now this entire value 1.6 into 10 to the power minus 19 coulombs, this is called as the standard electronic charge, which is written as small e. Okay, this value 1.6 into 10 to the power minus 19 coulombs, it is collectively written as the standard electronic charge E. And so we call that protons carry plus E amount of charge. Okay, so when we say plus E amount of charge, or simply E, the amount of charge present is E, we mean that it has 1.6 into 10 to the power minus 19 coulombs. When we say that electrons carry minus E charge, it means it automatically refers to minus 1.6 into 10 to the power minus 19 coulomb. So whenever you say, when we see the value or anything written in terms of E, it means it is 1.6 into 10 to the power minus 19 coulomb. It can be positive, it can be negative. Okay. Another important concept associated with charge is always quantized. Okay, each and every object which is there present in the universe, the amount of charge that is present in that object will always be in terms of integral multiples of E. Okay, integral multiples of this standard electronic charge. Okay, so what it means is that there will always be charge present in each and every object in terms of Ne, n multiplied with this standard electronic charge, where n is any integer. Okay, plus minus 1, plus minus 2, plus minus 3. There will be never any, you will never find the amount of charge present in an object like 0.5 e or 0.25 e or 0.75 e. There will be no fractional values. It will always be integer values. Okay, it can be positive and negative, but it will always be integer values. Okay, so and this E is the standard electronic charge, which is 1.6 into 10 to the power minus 19 coulomb. So it is a very important concept, which is the quantization of charge. Okay, now another important concept is the electrical neutrality of objects. Now most of the objects that we come across in our daily lives, they are electrically neutral. So what it means is that they carry no positive or negative charge in excess in them. They have the same number of electrons and protons in them. So the net charge, it cancels or balances each other out. Okay, so when you have the same amount of protons and electrons, they will nullify themselves, they will neutralize themselves, and in so the object, it will behave as a neutral object. Okay, so that is the concept of electrical neutrality of objects. Okay, all the objects, they have the same number of electrons and protons, and hence the net charge, it is neutral. they cancel or balance each other. So this is the concept of electrical neutrality of objects. The next important concept is the law of conservation of charge, which means that electric charge, it can never be created or destroyed. Okay, it can only be transferred from one object to another, but it can never be created. You cannot create electric charge, you can never destroy, it is already present. Okay, and the net charge for an isolated system is always conserved. Okay, we cannot uh, create electric charge, we cannot destroy it. Okay, we can only transfer it, okay, from one object to another. Okay, so this is the law of conservation of charge. So here we have discussed some other basic concepts related to electric charge. Okay, where we have discussed about the two kinds of charges, the unit of charge, the charge present in protons and electrons, the concept of quantization of charge, electrical neutrality of objects, and the uh, law of conservation of charge. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.